Hey guys, this is Ayush and welcome to another video guide. This is going to be on the linked list homework assignment. So I made a linked list class and node class and iterator class for it too, and I'll be just going over how they work because I made it so you can iterate over the linked list and you can iterate over the nodes of the linked list. And there's a linked list class which it has like an erase functionality, and you can push back an entire vector of numbers, and you can delete the list, and then yeah, there's a bit of stuff that you can do with it. It doesn't fully model the homework assignment, but it partially does, so it should be pretty helpful. Okay, so for the iterator class, by the way, the code for all of this will be in the description of the video below, so you can check that out. And this is the node class. You can see that what it has, pretty simple. And the iterator class has a bit of, this time it needs a little bit more functions than just the standard array iterator. Like for example, we need like an equals function, and we need that in order to make it iterate over something. And yeah, I'll show you that. And then we also have the list class. So we have when we say we have the begin function, which gives us an iterator, and then an erase, and yeah. So for the iterator class, we have these functions. It's pretty simple. Like you just make the current node become the current node next, and the reason why you can do that is because we'll get to that, but it's because we in initializing the list, we made the linked nodes point to each other, and then for operator equals, you can just literally just do that. So yeah, it's not too difficult. And then reverse iteration, yeah. Oh, and then that's another thing. So this operator equals, it's really a good thing to have for if you want to, like, let's say you're iterating over the linked list and you want to access the value that's pointed to by the iterator with using the arrow thing. I kind of had to make this function, or else the compiler wouldn't have let me do that. So now I can access the actual node that it's pointing to because of this user-defined function. So yeah, then we have our pushback function. So it takes in a vector, and then let me explain that. So you create a new node, and then that to hold a value at the first index of this vector, and then make the next be null and previous be null. And then so I have this function that will go through the vector, and for each element it will make a new node, set the new node's value to be that value at the vector position, and then the previous nodes this new node's previous connects to the original node up top, and then the original node's next connects to that, and then the original becomes a new guy. And at the end, I just do tail equals new guy. And then, so that's if the head is already null, but if it's not already null, then it's like literally just the same concept, same exact functionality, yeah. And delete list, so this is a kind of can be tricky if you don't get it right. The way I did it, I actually got this from geeksforgeeks.org. I set a temporary head to be the same as the head, and so I made like, okay, so while the head next is not a null pointer, you make the next node of the head you make whatever is pointing to the head null, and then you make the head become the next node, and then you delete what the head originally was. So like, let's say you have a list with like an element here, an element here, an element here, so you're just moving like that, and then you delete the original, and you just keep doing that until you're at the very end, and then finally your head is like the very last node, and you just set that to null pointer. For print list, I use my iterator because I created my iterator and I wanted to use it. So I can just do, the reason I can do this is because of the operator I made. And then that points to a node, so you can do the node, this is a node function. node class function. The size, it's pretty simple, just literally count the size. And then this is the begin function. You create an iterator that is you create an iterator that's a copy of the head. And then the reason you can do that is because of the iterator's initializer. So if we go up, we see that there we go. We can see that this is the initializer. And then yeah. And then the erase function, this is a little bit of a step upwards in terms of complexity. So, and I'm not sure if it's really necessary to understand this, but I think it was kind of fun to make it. So I'll just go over it. So I have this function for the iterator that gives us the current node that it's holding. And now if you can, I already defined what the operator equals, so I can use it here. So if we're at the head, and if it's the first, and if we're our size of the linked list is only 1, then all you do is have to delete the head. And if you're at the head but there's more elements, then I have to move the head next, and then I have to delete the previous of the head. And oh shoot, that's good. And then yeah, then I have to set the head previous to a null pointer. And then if we're at the tail of the list, then we make the tail become the previous node, and then tail next is deleted. And then if we're in the middle, then we do the previous of the next. I mean, yeah. So we go the previous, next of the previous. Sorry, it's kind of funny to pronounce that. Which is basically the whatever is pointing to the current node. Oh, we set. So it's like I have to draw a diagram. So if I have a node, and I have a node, then I have to set this pointer to point here, and then I have to set that pointer to point here, and then delete that guy when they originally were linked together like that. So that's exactly what I'm doing. So the next of the previous instead will point to the current node's next position, and then the other thing for the other way around, and then we delete the current node. Yeah. And here's some of the functions, and they all work. They're erasing elements, we're iterating, we're having a good time with this linked list. And yeah. Alright, the code will be in the description below. Hopefully this was helpful. Thanks for watching.